I'm Mike, and this is the 3D printer duct showdown. This time we're testing some crazy looking designs, so let's put 7 more ducts to the test to see if any of them can produce good or even great results on these high-speed torture tests. So stick around. In the last video, we had some results that were better than the stock duct, and we had some that were a bit worse. These are tough tests, and one duct might do well on one or more tests, but really poorly on another. And we're looking for the best overall. I think we've all experienced poor cooling on a 3D printer, and I have several videos on the subject already, so I won't go over it all again. I will just say that this all began for me when I first reviewed this printer, the FL Sun T1. And the fan was extremely loud, and one good way to quiet it was to have a better performing duct and then reduce the fan speed. And also the stock duct was blowing air directly on the nozzle, which caused the max flow rate to be greatly reduced. This is a pretty straightforward setup in this printer with quite a bit of room to play with for ideas for the best cooling, so I thought it was a really good candidate. So if you haven't watched any of the previous videos, I will put a link up there if you want to check one of those out first. Otherwise, let's dig in. First up, we have the Cuttlefish by Mobiobi, and if you've ever watched the fan showdown, Mobiobi has made an appearance on that channel, and I think he's actually still ranked quite high. This is a unique approach to the popular dual opposing design with the bulbous and very organic shape coming in at only 10 grams. It has a generative design look to it with an internal diverter below the fan supply inlet, and inside it has vertical walls to help keep the flow balanced from front to back. Those interior walls also have filleted edges, so there are no sharp corners. It also has this webbing to help strengthen the connection between the two sides of the duct, but it also looks cool too. The inlet size is 113 millimeters squared, and the combined area of the mouths are 148 millimeters squared. These oppose each other exactly, which means that we should see quite a bit of air moving forward and also back with this design as two streams meet each other in the center. That bulbous shape may have an advantage in less losses due to friction inside as well, and it's one of the quieter ducts that I've tested so far. Overall, it's a nice looking design, but how does it perform? This duct did very well on the Shuriken, far better than the stock duct, and quite a bit more uniform on each side as well. The Benchy came in slightly better with a little bit less trouble on the lower hull. Overall, a little bit cleaner and also less melted looking. This duct produced one of the nicest sides on the cliffhanger test that I've seen so far, but it was towards the back. On the front and the sides, the results weren't so good, and the stock duct actually did pretty well on that test. This duct has overall effective cooling, but like the Hiromi Delta in the last video, it seems like the air leaving the duct could have been a little bit faster moving in order to cool those tough overhangs quick enough. It is a little bit strange that the rear overhangs turned out so well though. And lastly, the bridge test. It did well on the sides, but where most of the air was leaving on the front and back, those first few bridge extrusions were moved around quite a bit. Once there was something in place for the extrusion to actually attach to, it improved quite a bit after that. Overall cooling is good for this duct, but where balancing of the air is concerned, it did suffer a bit. Next we have the Double Donut. This was designed by Ep.2 Garage, and he has his own channel and he's starting to get more into 3D printing car parts. I will leave a link down there below to his channel if you want to check it out. This is one of the most unique designs for a duct that I've ever seen. It is literally a double stacked donut. It makes me hungry every time I look at it. This is a full wraparound model, but still fairly compact and comes in at only 11 grams. This design uses stacked toroids, and if we have a look at the mouths from above, each tier is set to send air from a different direction, which should produce overall quite a uniform cooling, but it could also be pretty turbulent inside there as well. The upper tier also has those mouths directed downwards, so that it should place air quite nicely below the nozzle. Each mouth is only 2 millimeters in diameter, and there are 16 of them, bringing it to a total of just over 50 millimeters squared of mouth size. So this should mean that this model will build up some pressure, and the air leaving each should be at fairly high speed as well. It also means that it's going to restrict some of the air movement too though. I don't know what to expect with this one because it is so different, so let's check it out. For the Shuriken, the duct did better on one side than the stock duct, but not quite as good on the other three sides. The Benchy looks very similar to the stock duct, but near the hull, the results weren't quite as good, so overall it came in just below the stock. The results on the cliff hanger were pretty good. It's very similar to the stock duct and it produced overall fairly uniform sides. Some of them were slightly worse. And this duct did quite well on the bridge test, producing slightly better results than the stock duct, which had done pretty well on the bridges itself. When it comes to providing even cooling, this duct did really well, but because it is a bit restrictive, it can't cool quick enough to keep up, and we saw that on the Benchy and on the Shuriken as well. This is a unique design with a lot of potential, so I'd like to see this one opened up a little bit to let some more air through and see how it does. Next up, we have the Turbofan by Panagiotis Kaloneros, and this one is quite unique in its own right. It has the dual opposing design, but it's using pipework, and it also has sharp corners. This model is also very compact, coming in at only 9 grams, and it is so compact, in fact, that the silicone sock seems to be cutting off some of the airflow. I'm not sure if this is part of the intention of this design or not. It has these 2 opposing tapered mouths, and each of them has these 2 speed holes as well, which I believe are supposed to assist in drawing in air from behind to help supplement the flow. This model is giving off a bit of a steampunk type of a vibe. Each mouth has an area of 39 millimeters squared, which brings this model to 78 millimeters squared total, and that means that it might restrict the flow quite a bit. It is possible that those extra openings might actually help to release some of that air pressure, and if that's the case, we can include them, and that brings it to a total of 106 millimeters squared, so a little less than the inlet size. Because this duct has legs that feed the mouths, the air should be coming out fairly uniformly, and if the sock isn't blocking the flow too much, it has some potential to do really well. So let's find out. This duct struggled quite a bit on the Shuriken test. The results were not as good on any of the sides as the stock duct, unfortunately, and the Benchy looked a little bit worse in some areas but better in others. Overall, it didn't quite look as good as the stock duct either. The cliffhanger test performance was quite good and produced uniform overhangs on each of the sides, and overall I'd say it performed just a little bit better than the stock duct on this test. And this one also did quite well on the bridge test, again producing uniform results, straight extrusions without any twists, and it produced slightly better results than the stock duct here as well. So where a more uniform flow is needed, this duct surprised me and did quite well. However, this duct did not have the ability to cool the parts quick enough, and it wasn't able to keep up on the Shuriken or Benchy tests. They weren't quite as good. But the results were actually pretty surprising because the silicone sock was blocking some of the air leaving the duct, so it might have some potential to do even better with a little tweak to the design. Next up we have Lucra Hulk by Dave, and this one is based on the Separatist blockade battleship from Star Wars. This one is one of the smallest ducts that we have in the competition, and I believe it is tied for the lightest at only 5 grams. This model is surrounding the nozzle with these very small mouths which are arranged horizontally to the nozzle. Each opening is only 1.76 millimeters squared, bringing the total area leaving this duct at 28 millimeters squared, which is also the most restrictive duct that I've seen so far. This model is quite nice looking though. It allows great visibility to the print as well, which I do appreciate. But there is one possible major issue, and that is that the streams of air are directed exactly towards the size of the nozzle and not below it. Going back when I tested this printer out, that was one of the main problems with the stock duct too. Too much air was going towards the nozzle, cooling it down. Now, I'm not sure if this was intentional or not. I have no idea what to expect from this duct. Maybe I'm missing something, but it seems like this could be a big problem. So let's find out. For the Shuriken, the results sadly were really rough and gooey, and the same goes for the Benchy. It was very melted. The concept for this duct is solid, but the duct is so restrictive that it just can't cool the part quick enough. Possibly an even bigger problem is that the mouths are set to direct air to the sides, and this is where I had some trouble with this duct. All of the air that was coming against the nozzle caused a thermal fault on the first Benchy test. Luckily, I was able to run it again, and I was able to get it to finish. Now this duct is so restrictive that there wasn't too much air coming towards the nozzle, luckily, so that was kind of a close call. The overhang test really surprised me. It actually did fairly well, and I'd like your thoughts on why that could be. The results on some of the overhangs were slightly better than the stock, and some of them were slightly worse. Overall, seemed to be a bit of a draw on that one. With the bridge test, this one again was strange. The extrusions seemed to be inconsistent and blobby. They're fairly straight, but my guess is that this is just due to the lack of adequate cooling. Maybe also due to the warm air moving down from around the nozzle. One end didn't even attach properly, which is the first test like this that I've seen that problem come up on. So yes, this duct has some issues, but I think the design has some potential as well. If this could be made a bit larger with larger mouths to just a little bit less than the inlet size, along with directing the air slightly down below the nozzle, it has some serious potential. Sadly, as it is not able to keep up, but let me know what you think about this one in the comments there. Next up, we have Ducty McDuct Face, and this one was designed by Single Overhead Cam Head, and it is certainly one of the most refined ducts in the competition. It is also one of the heaviest ones, coming in at 18 grams. It looks a bit like some of the other full surround models. It also has this aerofoil shape similar to some of the newest Dyson fans with the outlet towards the front. This means that it might be able to induce air coming in from behind using that same air amplification principle as the wing of a plane or the bladeless fans. This one has a unique diverter setup which separates the air into three, and it is diverting most of the air to each of the sides and a little bit to the back. If this wasn't done, more air would want to leave towards the rear because of how close it is in proximity to the inlet of the duct. If we look inside, it has even more guidance for the flow, and it seems to be set up to guide less air to the ports closer to the inlet and more air to the ones further away. So from what I'm seeing, this duct should produce a pretty even flow directed below the nozzle. Now, because this design surrounds the nozzle with air, it is likely going to force the air down as well. There is a fairly large opening inside. The air may go up also because of that. Now, the duct has a total of 20 ports of various sizes, but overall has a mouth area of 116 millimeters squared versus the inlet of 113, so pretty similar, and it should produce fairly fast moving air and even possibly more if we consider the air amplification possibilities as well. So let's find out. For the Shuriken, we have pretty good results. It performed better than the stock duct on two sides by quite a bit, and about the same on one side and a little bit worse on the best side from the stock duct. So overall better than the stock, but another interesting thing is that the shaft of the Shuriken was far cleaner than the stock duct on this print, which I would imagine is because of the much more uniform cooling from all sides that this duct can provide. The Benchy test produced an all-around better result than the stock duct, and it is one of the best Benchies that I've seen tested so far. It still struggled with the lower hull, but not as much as the other ducts did, and there are no voids, at least in that area. This duct performed really well on the cliffhanger, also producing uniform results on each side, with the rear overhang looking like it was the best. Overall, it performed better than the stock duct on this challenge as well. Lastly, the bridge test, where uniform flow is critical. For this test, the duct performed well, but again, some of those first extrusion lines became tangled up or were moved around or out of position. After the first few extrusions were in place, it did far better. Overall, it came in slightly below the stock duct for the bridge test. There are a few key details with this design that I believe help it to perform well. It has an aerofoil shape to help bring in more air from behind, but it also has a place above for the air to escape, and it has room below as well. From what I've seen so far, this duct is a solid contender and has some serious potential. Next up, we have the Hurricane Quadro by Alexander Zorgel, and this one looks similar to some that I've designed and tested in previous videos, but it is actually quite a bit different. First, it takes the inlet and separates it into four. Then each of those ducts is then separated again inside, and that helps to balance the airflow. It does have different lengths of each of those legs of the duct, so it still may impact the balance a little bit. But the idea, I think, is to try and get the flow as even as possible through each of them. This one comes in at only 10 grams, so overall still fairly light, very good visibility to the nozzle as well. Alexander went with a bit different direction with the mouth and made them larger. Normally the duct would be larger and then the mouth would be smaller. And I was curious to know why he did this, and he pointed out that the mouth changes in height just at the top, and it also widens to spread the air out a bit better too. So that's an interesting approach that I have not seen done before. This duct has a total mouth area of 92 millimeters squared, so it should produce streams of fairly fast moving air, and each of the mouths are directing air towards the bottom of the nozzle. They're not offset to the side of the nozzle. The streams should really converge fairly centrally right below the nozzle. With this design and how open it is, there should be quite a bit of space for air movement around the ducts, so the warmed air will have a place to leave. For the Shuriken, this duct did quite well. It seems to have done better on every side than the stock duct. And again, like Ducty McDuckface, it also produced Nice crisp vertical walls, unlike the stock duct. The Benchy also looks better than the stock duct. Again, it struggled with the lower hull, but the results improved quite a bit as it made its way up higher, and it even did really well on the chimney pipe to cool it as quick as possible, which most ducts actually struggled quite a bit with. The cliffhanger test did really well. It produced uniform results on every side. It also performed quite a bit better than the stock duct on this test too. For the bridge test, this duct still performed well. It had a little bit of trouble on the outermost bridge lines on both the longest front and the back ones, but on the rest the results were pretty good, and they were about in line with what the stock duct was able to produce. So overall, this duct performed extremely well with the wider openings on the mouths, the interior diverters, and the air directed towards the nozzle from 4 sides, along with a slightly undersized mouth to ensure fast-moving air is leaving. It seems to have a lot of what is needed for a great high-speed cooling duct. Because this duct also sends air from the sides mainly, it also doesn't force too much air downward, which helps for those overhangs and bridges. This duct also seems to have quite a bit of potential. Lastly, we have one of the biggest ducts to enter the competition, and it is also one of the most unusual looking designs as well. This this model is called the Loop X, and it was designed by 10101, which I think is binary for question mark. This model is the second heaviest, and it is easily the hardest to remove the supports from, and it still actually doesn't even look that good on the bottom. So aside from that, this model is quite different again from anything else. It takes the inlet and splits it into 4 square shapes, which then transition gradually to thin and very wide rectangular mouths. And because of the length of these 2 forwardmost legs, there is also a ring to connect everything together near the bottom. This is nearly fully surrounding the nozzle with air. The ports each measure at 28 millimeters squared, so that gives us 112 millimeters overall mouth size versus the 113 for the inlet. So the airspeed should still be fairly fast moving as it exits. At the bottom of the initial transition into each duct, there is a slight diverter inside as well, but not very much. So let's give this one a go and see how well it works. For the Shuriken, it performed better on 3 out of the 4 sides, and again produced very nice smooth vertical walls compared to the stock duct. So it had better performance than the stock duct on that test. The Benchy overall was better as well. The left side near the bottom didn't look quite as good as the stock duct, but the rest of the model was better, especially the front lower hull. So this duct performed better on the Benchy test than the stock duct as well. For the overhang test, the results were pretty good, but not exceptional. There were 2 overhangs which didn't turn out too well. Overall, it came in slightly behind the stock duct on this test. And for the bridge test, there was a small amount of twist on a couple of the longest bridges, but otherwise the results were quite good, and it looks slightly better than the stock duct. So this duct did pretty well. The balancing on the duct isn't probably quite right, but it isn't necessarily too bad of a thing either. The shorter ducts will tend to release more air than the longer, more swooping legs of the duct, and the inlet versus outlet sizes seem to be quite good, so we'll have overall a good amount of fast-moving air towards the nozzle. This duct could probably benefit from a diverter setup to get a bit better balancing on each mouth, but overall, quite good performance again. I screwed up. So when Obi sent me the original email, I went ahead, printed this model right away, but soon after he sent me a follow-up email with a slightly modified version, and that was to balance it out a little bit better from front to back. So the diverters that are in the center here were slightly adjusted. So what I just showed was the old version. So I went ahead and printed this version in black just to keep them apart. This is the slightly modified version with the diverters changed inside. So it should balance it out a little bit better. I went ahead and reprinted everything. And guess what? There is a slight difference. On the Shuriken, slightly better performance. The Benchy test was a little bit difficult to tell apart. I wouldn't say one was better than the other one, but the cliffhanger test actually was a little bit different. It performed slightly better on that test as well. And again, towards the back, it actually did really well also. But for the bridge test, I wouldn't say one was any better than the other one. They both had the exact same problems in the exact same areas. So I've come clean with my screw up Obi, and this one definitely does overall perform better than the original duct. If you enjoy this content, make sure to subscribe and notify to catch next week's competition where we finish up testing the rest of the ducts and select the ducts. that perform the best to see which ones are going to advance. Thanks for watching, and as always, if you want to help support this channel, I have a very short list of quality products in the video description that I use in my shop on a regular basis. And also thank you to each of my patrons for helping to make these videos possible. And of course, if you want help as well, there is a link down there below. Take care, and we will see you on the next one.